All right, so this is going to be the last set of truth tables that we discuss, and these are called biconditionals. So what a biconditional is a conjunction, hopefully remember that word, of a conditional and its converse. Okay, so a conditional, hopefully you realize that a conditional is if P then Q. Its converse is change order, if Q then P, and the conjunction is the statement and. Okay, so this is what a biconditional is. It basically says if P then Q and if Q then P. So the simplified form of that is, well, let's get rid of these two parentheses and let's do one of these things. Instead of having a single arrow, let's do a double arrow. So we've got this P, this double arrow Q, and this is read as follows. P, statement P, if and only if Q. So that's a biconditional. Bi meaning two ways. We've got this double arrow. So a biconditional is the conjunction of a conditional and its converse. It's P if and only if Q. So the way this works is you're going to write the biconditional joining P and Q, and we're going to state the truth value, but we're going to do a piecemeal, right? So the first thing we're going to do is we're just going to write the basic conditional, the statements if P then Q. And you've got those statements up top. So the first part would be is if P, if triangle ABC is equilateral, I'm hoping you know these definitions, then triangle ABC has three equal sides. Okay, hopefully the equilateral means all the same, and then this would actually happen to be true, right? If ABC is equilateral, then ABC triangle has to have three equal sides. So this is true. Then it says, okay, well, let's write the converse sentence. And the converse says, well, if Q, then P. So if triangle ABC has three equal sides, my earrings keep hitting this thing. I'm sorry if that's annoying. Then triangle ABC is equilateral. Well, let's think about that for a second. Okay, so if I've got three equal sides, am I equilateral? Well, of course I am. So this is true as well. So let's do the biconditional. Remember, the biconditional says P if and only if Q. So then we're going to say, okay, well, P, triangle ABC is equilateral if and only if triangle ABC has three equal sides. Well, this also hopefully would make sense to you too, because remember, we're saying that the biconditional is the conjunction of the conditional and its converse. So I know that the conditional was true, the converse was true, and I'm looking for a conjunction. Well, TNT means I cleaned my room and I did the dishes. I am most definitely going out. So the true statement of this particular biconditional is also going to be true. We've got a truth table for this. Now this is a scenario that we talk about. It doesn't really have a story to it. It's more of when you multiply integers, signed numbers. What happens when the signs are the same versus the signs being different? So we're going to start our truth table out the same way. TT, TF, FT, FF. So this is like saying, okay, integer rules. If I've got a positive or true times a positive, which is also true, my answer comes out to be positive, which is true. If I've got a positive times a negative, the answer is negative. Well, that would be like a false connotation. If I have a negative times a positive, the answer is a negative. So false and a true is a false. And if I have a negative times a negative, hopefully you remember that that's a positive. Okay, so here's your truth table. So a biconditional is true only when, now take a look. When are we true? We were true here and we were true here, which means I'm only true when the hypothesis and the conclusion have the same truth values. Right? That should make a lot of sense. In other words, in order to be true, both statements must be both true or both false. It's like, again, it's like the rules when you multiply or divide, for that matter, signed numbers. Two positives is a positive. Two negatives is a positive. One of each sign is a negative. All right? Good luck on your homework.